Hello, in the last session we have discussed about the types of finite automata. So now let us discuss about conversion of non-deterministic finite automata to deterministic finite automata. So now this is the transition diagram and we have to write the transition table for it. I have already told you how to do it. Like A on 0 gives A, B, C, D and E. B on 0 gives C, B on 1 gives E, C on 0 gives nothing, so we write it as phi, and C on 1 gives B, and next D on 0 gives E, D on 1 gives nothing, so we write it as phi, and E on 0 gives nothing, E on 1 also gives nothing. So this is our final transition table for NFA, non-deterministic finite automata. So now we have to write the transition table for DFA. So let us write as it is table, like write this as it is till here. Okay, it is the as it is table till here. Now what we have to do is, here we have a group of states when A transitions on 0, right? But this is against DFA. So what we do here, we consider A, B, C, D, E, this whole thing as another state. And what we do is, so A, B, C, D, E on 0 gives A, B, C, D, E, C, phi, E, phi. So we'll take union of all these. So what are all the terms that are here? All the terms. So I wrote all the terms here. Next, A, B, C, D, E on 1. What does it give? A gives D, E, B gives E, C gives B. These two are phi. So what are the terms here? B, E and also D. So B, D, E. Next. Here there is another term which we need to take, so D comma E. So I took D comma E as another state. So D gives E, E gives phi. So D comma E on 0 is E. D comma E on 1 gives, both are phi, so we take it as phi. Next, B, D, E. Go to B, D, E. Why did we take B, D, E? Because we got B, D, E here. So we are considering this as another state. So B, D, E gives C, E, phi. So C comma E. Next, B, D, E gives E, phi, phi. So it is E. Next, we got another new term, that is C comma E. So let us consider C comma E as another state, and C, E both are phi. So I wrote here phi. C, E gives B, phi. So I wrote B over here. Okay, so this is the transition table for DFA, and now we just have to draw the diagram. Don't be tensed about how to write these terms. Write in any manner, write A, B, C, D randomly. You just have to map it accordingly. So I wrote A, B, C, D, E, D, E, B, C, D, E, B, D, D, C. You can write it in any manner. So A on 0 gives A, B, C, D, E. So A on 0 gives, this is considered as one state, right? So A on 0 gives A, B, C, D, E. A on 1 gives D, E. A on 1 gives D, E. B on 0 gives C. I wrote here B. So B on 0 gives C. B on 1 gives E. B on 1 gives E. Next, C on 0 gives phi. So we are not gonna do this transition. C on 1 gives B. So C on 1 gives B. Next, D on 0 gives E. D, where is D? Yeah, D on 0 gives E. D on 1 gives phi, so it doesn't matter. E also doesn't matter. Next, A, B, C, D, E. So A, B, C, D, E on 0 gives itself, like self state. So A, B, C, D, E on 0 gives the same thing. So A, B, C, D, E on 1 gives B, D, E. So A, B, C, D, E on 1 gives B, D, E. Next, let us do this B, D, E. Yeah, we can go with D, E if you want. Next, D, E. D, E gives 0 on E. D, E, sorry, I didn't map this. D, E on 0 gives E. So map this. Next, DE on 1 gives phi, so we don't have to map it. BDE on 0 gives CE. BDE on 0 gives CE. BDE on 1 gives E. CE on 0 gives phi, so we don't have to map it. CE comma 1 gives B. CE on 1 gives B. So this is the new transition table for DFA. Okay, we converted this to this.